Extremely sorry, we got delayed today by almost 11 minutes. Actually, we had faced a little technical problem, so because of that, we got delayed. Anyways, how was your Diwali celebration? How many of you have burned things on Diwali? Okay, so we discussed so many projects in our previous sessions, and I appreciate your efforts and your interest you had shown and you are showing uh, today also, and even appreciate your patience you have shown it now because we got delayed by 10 minutes. Okay, now we'll start with our new projects. But before that, I want to show you uh, one of the project which we have made to show you that what is digital input and what is analog input. As you are seeing on the screen, here what we have done, we have used two multimeters which will be showing you that what level of potential we are applying at the input and what we are getting at the output on actuation. And this is the case when we are talking about digital input and digital output. So here on the screen we have our two multimeters. One is connected at the input and which is pin number 2, and we are checking output on pin number 4. So let's see. So if I start the simulation here, so as you're seeing, the 5 volt is connected to this push button, and this push button is passing this 5 volt to pin number 2. And parallelly, we are checking this input on the display on this multimeter. So if I press this button, so what we are seeing, we are applying 5 volt at the input, and on applying 5 volt, we are getting 5 volt at the output. And I told you that in digital, in electronics, what we say, if it is logic 0 or logic low, it is called as 0 volts, and if it is logic high, that is called as 5 volts. It may be different in some controllers, it may be 3.5 or some other values also, but as per the standards, what we consider that the logic high is 5 volts. So if I press this 5 volt, this button, what we are doing, we are passing 5 volt signal to the input. That means we are applying logic high. And what we are getting at the output, we are getting 5 volt at the output. So this is digital input and digital output. And if we see at the code, so what we are doing, we are reading a signal, we are reading digital pin 2. If it is high, then set the pin 4 high, otherwise keep it at low. So when it will be high, when we'll be pressing this push button. Or simply you can say that when we apply 5 volt to the input pin 2, digital pin 2, we will be getting digital output at pin 4. And just to show you, we have connected these two multimeters and checking the values of the potentials. Hope you have understood the concept. Rahila Khan, good afternoon. Senoy, good afternoon. Bithals, good afternoon. Shabd Seni, good afternoon. GCM, GMart, good afternoon. And this Gauri Saxena, good afternoon. Pratika Agrawal, good afternoon. Good afternoon to all. Have you got the idea of, have you understood that what is digital signal or digital input or digital output? Okay. Now, moving to our next example, which we have used to show you analog input an analog output. So now in this example, what we have used one analog device where we have used one potentiometer to apply variable potential at the input, and parallelly we are checking the output on pin number 3, which we are using as analog output. So here, with the help of this potentiometer, we will be applying different potential levels. You can see here on the screen, I have started the simulation. So if I am changing the position of the wiper on the potentiometer, my output value is changing parallelly. So if it is 0, 0 volt, 200 millivolts, 300 millivolts, 600, 700, 900, 1 volt, and maximum up to 5 volts. So what I am doing, I am applying variable potential at analog pin A0 using this potentiometer. So what we are seeing here, that we are applying different potential to analog pin A0, and since it is an analog, so definitely there will be the variation in the values, and the values, whatever variation is there at the input, we are seeing the same variation at the output because we have programmed it in this fashion. So you can check the program also. Set pin 3 according to the values which we are reading on A node. Now we have used this instruction. This is a very new instruction for you people which we haven't discussed in our previous session. Mapping. What we have used here, that we are reading the analog values coming or receiving at analog pin A node, and parallelly we are outputting the same values on analog pin, output pin 3. But we have used this map command over here. What this map command is doing here, actually the input is in the range of 0 to 1023 range. I'll show you on Word file. So what we are doing, what we are getting, a value on analog pin in the range of 0 to 1023. But in Arduino, this output pin number 3, works in the range of 0 to 255. So what we are doing on analog pin A0, I'm writing it here, on analog pin A0, range of values, is 0 to 1023. So it is internal programming that they have according to digital pattern, the value of 0 to 5 volt. What is our actual value which we are applying? Our actual value is 0 volt DC to 5 volt DC. But it is internally converted in the range of 0 to 1023. Similarly, on output, our range is on log pin A, pin 3, analog output pin 3, range is 0 to 255. And actual value is 0 volt to 5 volt. But internally, what is happening inside the controller? They are considering the value 0 to 1023. And at the output, internally what is happening? The controller is considering 0 to 255. Therefore, what we have done, we are we have mapped it that whatever value we are taking at A node will be outputted at pin number 3 in the range of 0 to 255. We'll discuss it in detail when we'll be conducting offline training in coming months. Don't worry, just think it in this way that we have mapped two different values because they are in different range. But anyway, our motive is to tell you here that whatever analog values we are inputting at A naught, the same values we are checking at the output, and you are seeing here in the example. So this is what our analog input and analog output. Okay. So now Tyrannosaurus. Okay. Now we'll check with our project, which is our main focus in today's session, and that is mobile robot. How many of you wanted to design your own mobile robot? You might have seen different boards. Sometimes we also say them boards or mobile robots in videos, in YouTube videos, in different places. They might be used for different applications. Some of people use these boards as line followers. Some use them as handheld. They control by handheld device. So there are different type of robots used in the market, and uh, many of the students, they are fascinated about these technologies. They want to design their own robots, and seeing the interest from which we have seen in young students, we thought to make this project for you. But this is basic mobile robot project. What we have done here, we have used two motors. So this is the chassis. We have used two motors over here, and we'll be controlling the movement of these two motors to move the boat in forward direction, in reverse direction, to turn the robot in left to left or to right. And how we are accomplishing uh, this application or this movement of the robot with the help of switches. So what we are doing with the help of switches, forward switch, backward switch, left switch and right switch, we will be moving our robot in forward, reverse, left and right direction. So as you are seeing on the screen, what basic components we have used. We have used two motors, DC motors, but these two DC motors are geared one. And we have used one IC which we have discussed in our previous session to this motor driver IC. We have used these for push buttons to operate the robot. So let's check the simulation here. As you're seeing in the simulation, when I press this stop button, which is used for forward to move the robot in forward direction, so what you will see that both of the motors are running in forward direction with a maximum speed of 231 revolution per minute. If I press this bottom button, which is used to move the robot in backward direction, you will see that now both of the motors are rotating at the same speed but in reverse direction at minus 231 revolution per minute. But let's say you want to rotate or you want to turn your robot to left, so I'll be using this left button. If I press this left button, one of the motor will be moving in forward direction and another will be moving in reverse direction to turn the robot in left. And in the similar way, if I press this right button, which is used to turn the robot in right. One of the robot will be moving in the forward direction and another in the reverse direction. So what is happening? By using this, in one case both of the motors are moving in the forward direction to turn to move the robot in forward, and if I press the back button, the motors, both of the motors will move in the reverse direction. So motor will be moving in backward direction. And if I want to turn my robot to left, so what I need to turn this, I need to run this motor in forward and need to run this motor in reverse. Doing this, my robot can turn to left easily. We have another option also. We can keep this motor in stop condition, and we can turn or move this motor in forward direction. So robot will be moving like this in left direction. In the similar way, if we want to turn our robot to right, so this motor will be moving in the forward direction and this motor will be moving in reverse direction. So forward, reverse, turn right, and if it is forward and it is reverse, turn left. And if both the motors are moving in forward direction, robot will be moving in forward direction, and in reverse direction we need to rotate the motors, or we need to make the motors move in reverse direction. So like this we can program or we can design our own board or mobile robot with the help of Arduino, 2 motors and 4 switches. And since we know that Arduino is not capable to feed motors with the potential which is required, therefore what we use? We use one additional motor driver IC L293D. And as you are seeing on the screen, what we have done, we have connected these 2 motors with this L239 IC. And I have shown you in our previous session. This is our mobile robot, which you are seeing. We have this robot is fitted with ultrasonic sensor also, servo motor also, and this mobile robot will be moving and checking for any obstacle. Whenever it will find any obstacle, it will be turning towards left or right based on the condition of obstacle in front of it. But in previous session I have shown you this, I have shown you the connection diagram for L293D, where we have 2 motors connected to this. These 2 output pins, output 1 and output 2, will be connected to motor 1 terminals, and on the right side these output 4 and output 3 again will be connected to second motor. Then to operate the motor in forward direction and reverse direction, we need 2 input pins from the Arduino. So 2 input pins from the Arduino will be connected to input 1 and input 2. So these 2 pins will be for motor 1 to drive it in forward and reverse direction. And in the similar way, to drive this motor 2 in forward and reverse direction, we will be having 2 more pins from the Arduino, which will be connected to input 3 and input 4 of the IC. And I told you that if it is 0 0 on the pins, let's say input 1 and input 2, motor will not run. And if it is 0 1, motor will be running in forward direction. If it is 1 0, motor will be running in reverse direction. And in the similar way for motor 2 also, based on the condition of the pins connected to input 3 and input 4, our motor 2 will be running in forward and reverse direction. I'll show you this also. Let's say we have motor 1. So for motor 1 we have input 1 and we have input 2. So now if input 1 is 0 and input 2 is also 0, I'll make it a little big so that it become visible to you all. So what we have done here, what I am showing here, that for motor 1 in L293D IC, we have two pins, input 1 and input 2. If it is 0, 0, motor will not run. If let's say if it is 0, if it is 0, if it is 0 and input 2 is 1, then motor will be running in forward direction. Let's say in forward direction, and if it is 1 and input 2 is 0, motor will run in reverse direction. And I had given you one more condition, 1. What will happen to 1 and 1? And it is up to you how you have programmed it. Motor will not operate or run. So at 1, 1, what condition we have used? That motor will not run. So this is the condition which we need to apply to the motor to run it in forward and reverse direction. That's why what we have done here, that's why we have connected our input 1 to pin 2 of Arduino and input 2 to pin 3 of Arduino. And the same thing we need to do to operate motor 2. So same condition will be applied for motor 2. Then we have this power pin 1. This power pin 1 is connected to plus 5 volt. We have taken it from Arduino only to drive this IC. But to drive the motors, we need an external battery. So external power. So we have used one 9 volt battery and we have connected this 9 volt battery to power 2 pin. So this 9 volt battery will be operating these two motors. But how these motors will be operating in forward or reverse direction, that will be dependent on the condition will be applied by Arduino. Then we have this enable pin because we are not varying the speed of the motor. So we will keep them on plus 5 volt. So this enable pin 1 and this pin number 9 enable pin 2 will be connected to plus 5 volt. If you want to change the speed of motor, if you want to increase or decrease, then you need to connect with it with the analog pin. But in this case, we are keeping the speed constant. So now look at here on the screen. We have connected this L293 pin number 1. This input 1 is connected to pin number 2 and input 2 is connected to pin number 3. So pin number 2 and 3 will be driving motor 1. Similarly, pin number 5 and pin number 4 will be driving motor 2 in forward and reverse direction. And you can see that power line enable pin is connected to 5 volt, which is connected here. You can see here this 5 volt from the Arduino is connected here, and from here we have applied this 5 volt to this power line 1. But this power pin 2 is connected to 9 volt battery. You can check it here. This 9 volt battery is connected to power pin 2. So this 9 volt battery will be driving these two motors. So whatever be that potential requirement of motors will be fed by this 9 volt battery. And then this enable pin 2, because we are not changing the speed of the motor, is connected to plus 5 volt constant potential. And same thing and another thing is output pin 1 and output pin 2 are connected to motor's terminal. You can check it here that this terminal, this line is connected to motor terminal 1 and motor terminal 2 is connected to output pin 2, which is here. And same thing we have done here for motor 2. Motor to this first terminal, which is shown by this yellow line, is connected to output 3, and another terminal is connected to output 4. It's not that difficult as it seems. It looks a little bit confusing, but once you will start connecting the motors physically using all the components in one practice or two practice, you will learn everything that how to connect these uh, devices with Arduino. Then we'll see these push buttons. This push button we have connected with 6, which is our input. This push button, this reverse direction, is connected to line to input 9. Then this push button for left is connected to input 8, and this right push button, which is for to rotate the motor in right direction, is connected to input 7. So these switches are sending the signal to input lines, which are our 6, 7, 8, 9. So 6, 7, 8, 9, 9 are our digital inputs, and 2, 3, 4, 5 are our digital outputs connected to motor driver L293D, which is driving our motors. So once again we'll be checking the operation in the simulation. If I press the top button, our motors are rotating, are running in forward direction. If I press this backward button, our motor is rotating in reverse direction. If I press this left button, our motor is rotating in left direction. And similarly, at last, this right button to run the motor on to the right. So you can design I purchasing these push buttons from the market, motors from the market, Arduino, this L293D, and then mount them on some sheet or board. You can take acrylic sheet, mount them there, make the connections, and then you can design your robot, which will be operated manually by hand. But if you want to, this is purely a manual uh, arrangement, manual operation of the motors. That means whenever you need to operate the robot, you need these buttons to operate it in a certain condition. But if you want to, and if you want an autonomous bot or robot, then you need uh, more components. Let's say you want a robot which will be moving following a line, which sometimes also called as a line follower robot. So those robots follow a line, let's say black line. We make a black line, a black strip. So that robot will be following that black line. So in that case, if you want to design such robots, you need infrared sensors along with your basic controller Arduino. So you need infrared sensors. If you want obstacle avoidance robot, that means you want to design a robot which can run in open space on the surface, and whenever it will find an obstacle, it can avoid it. So that robot is called as obstacle avoidance robot. You can also operate your robot with the help of Bluetooth. So you have to add a Bluetooth module. We have designed, you can check on our YouTube, on our channel. There we have designed that robot which is operated by uh, Bluetooth application. So you need to put one Bluetooth module over there, and you can operate your robot with the help of Bluetooth. So we need to interface a Bluetooth module in our robot, and there are various options we have to design our robots. You can design your firefighting robots. You can design a surveillance robot. You can mount a camera on the robot, and you can use it for surveillance. So now this is our basic robot circuit diagram. which we have seen here. Only thing is that you need to fit these two robots on the chassis. You need to fit the wheels and this controller and motor driver, and there you go. You can design your robot. Okay. Is there any confusion here in this circuit? I'm checking your comments. If you have any confusion, please write it there. Sanket and Rehan are there. They are helping you. If you have any query, any comment, you can directly put there. He is also assisting you in learning this these technologies. Okay. Now, last time also many of you have told us that there is a new module added by Tinkercad Microbit. So we'll be discussing about Microbit controller today in this session. So what is Microbit? Actually, Microbit is again a controller designed specifically for kids, so that kids can practice coding and they can design their own models, projects, DIY projects by themselves without having any problem. And it is very compact. The size is very small, and they have designed it in a way that it has almost all the main sensors and facilities there on board only. And you will not believe, in 2016 it was distributed to all the kids who were falling in age of 7 years, free of cost. So in UK, this Microbit people, they have distributed this controller to the kids in UK in 2016. So what is Microbit? Yes, Rehan. Shabd Seni. We have a comment from Shabd Seni. He is asking that you ask to take more free sessions. Yes, Shabd Seni, you are right, and we are planning for more free sessions, but not only with this technology. Now we are planning to conduct free session for mobile app development, where we'll be teaching you that how you can make your own Android or iOS application by yourself only. So in our next session, and we are also planning to teach you machine learning, or you can say artificial intelligence, and its applications. So we are planning free sessions for artificial intelligence for kids and mobile application development for you people. uh, and we for now we are closing this session with these technologies, with controllers and all, in today's sessions only. So today is our final last session about the projects. In our next session we will be uh, will announce the winner for kit. And I want to announce one more thing, that we have will be awarding certificates to all who are participating in our um, uh, training. But those who are participating and will be submitting the project, which I'll announce after a few minutes, those who will submit those projects to us will be eligible to enter in the contest, where you will win, where any one of you will win one Arduino practice kit. Apart from that, our collaboration Signum Academy has announced 2 gift hampers for students who have joined at least 3 sessions. Out of these sessions, who have joined or marked attendance in at least 3 sessions will be eligible to win 2 gift hampers from Signum Academy. And we have announcing discount coupons also. So 3 winners, that means one winner who will win a kit, Arduino practice kit, and 2 winners who will win the gift hampers. That means total 3 winners will also get a discount coupon of 10% for attending or for enrolling in coaching, which Signum Academy, actually Signum Academy is in the field of giving coaching to students for IIT, JEE. So you will be eligible to take discount of 10% with the help of that coupon. And we are planning for offline training in next session in 2021. So you will be eligible to get 10% discount in our training also. So these are the announcements which we thought to announce today in this session. So in next session, that means final session next week, we'll be announcing winners. Session 5th, as I told, educational learners, session 5th will be is planned to announce the winners. So randomly, by online medium only, we'll be selecting any 3 winners, and which will be announced next week. Again, we'll be having a session, a short session next Sunday. So we'll announce the winners on that day, and we'll be announcing the next training also, that on what topic and on what technology we will be delivering free training for you people in next session. Okay, so now coming back to Microbit. What is Microbit? Microbit is again a controller which is fitted with accelerometer, a magnetometer, Bluetooth module, light sensor, temperature sensor in itself only. And there are 25 LEDs there on the controller itself. So this Microbit is used to design your small projects. You can design your mobile robot, you can fit it in any application in which you want to design by yourself. And since the size is very small, you can use it easily anywhere. But to use maximum of it, we need one expansion module with Microbit. So this small device is not enough to execute our projects. So we need one expansion module to make a maximum use of this Microbit technology, Microbit controller. Anyway, this is our Microbit. As you're seeing, if we check the simulation, I'm running the simulation. If I press this button, it is displaying A, left button. If I'm pressing this right button, it is displaying B. So these 25 LEDs are used to display characters, numbers, or some sort of figures also. Let's say you want to display smiley, that's also possible to display on these LEDs. Now we'll check the code. The code is quite simple, where we have given in the library itself this LED, this block of LEDs. Let's say you want to display on button A, when pressed you want to display A. If you want to change it, you can change it. Let's say button 1, you can display 1 also here. If we press B, will display B. So whatever be you can change the setting of these LEDs. When you press these LEDs, it will be indicating as white. White means glow, and this blue means, that means in off state, white means in on state. So whatever LED you want to glow, you click them and turn them in white. That means you want to glow these LEDs when the condition will be true. So when B button condition is true, that means when it is pressed, then B will glow on the LED. Yes, Rehan. AB button. Then another condition is there. If we press this 2A plus B button, then you can display smiley on there. But because the simulation is not possible to press these both of the buttons at a time, and it's difficult to show you that pattern on the screen, but that is also possible. So again, will check the simulation. If I press A button is displayed there, if B is displayed there. So this is very basic application which I have shown you. Now I will show you another example of this microbit, where what we have done, we have programmed it to display a message. And one more thing is there, how to program it. This microbit is programmed with the help of Python. Python is a software, a programming language. So with the help of Python, we can program this controller. And there is make code. There is a online portal by Microbit only, where you can program it. Now we'll check the simulation for this. So what you are seeing here, that it is displaying a message there. Okay. Educational learner. What is Microbit? Okay. I'll show you. So what is there? It is displaying a message there. And what is that message? Hello innovator, TECHOOL technologies. So this is again a predefined block or programming block mentioned there in our Tinkercad, which you can uh, bring and drop it there and use it in your programming. So it's simply to display a string of character. You can take that block from this side and use it. This is a block. Take it there and put it there. Write whatever you want to write it there. You want to write it in the section. Let's say I want to write here, my name is Anis. So I want to write here Anis. And then I want to display TECHOOL technologies. Or you can say Anis is awesome. Anis, I'm writing is awesome. I'm praising myself. Anyway, I want to write it. Anis is awesome. Let's say I want to display this. I'll play the simulation. Now it is writing Anis is awesome. Am I? What do you feel? Okay, this is a joke. I can make joke, isn't it? So this is how you can use your microbit to display characters, or you can say images there, or things like by using these blocks there in your character. So instead of writing this, I want to display A there, I'm writing the pattern over here for A. So to run the pattern, what I am doing, I am glowing these LEDs. Whatever LEDs I need to glow, I am programming. So what will happen now? So this will be Anis is awesome. It's not awesome. Anis is not awesome. It will be displaying A. I made a little mistake. Anyways, we'll move to next. We are running out of time. We'll move to next project of Microbit. Again, I'll tell you what is Microbit. Microbit is a controller which is used to execute your small projects, your DIY projects, and it is specifically designed for small kids. And it was distributed free of cost in United Kingdom in 2016 to children who are in age of 7 years. Now I am going to show you one of the example of microbit where we have interfaced one potentiometer with the microbit. So this is our potentiometer and we have interfaced it here. Now what we have done here, with the increase in the level of potential applied at the input, the LED's level will keep on rising. And I forgot to tell you, we have onboard terminal 0, 1, 2. These three terminals can be used as in analog input and digital input output. And as I told you, to use maximum of its pins, we need one expansion module. So now as you are seeing on the screen, we have interfaced one potentiometer here, and as you are seeing, it is operating at 3 volt, where Arduino was there, which was supplying 5 volt, but it is having 3 volt. So we are applying 0 to 3 volt this potentiometer, and from the middle terminal, this terminal, we are getting variable potential. And as you are seeing, if I raise the potential, my LEDs rows are energizing on the level of potential I am applying to microbit. Isn't it amazing? So like this, you can interface your analog input, or you can say your analog device to this microbit. You can check the program also. Program is simple. Plot the bar graph, and we are reading the value at P node. It is marked as P node, P1 and P2. Whatever value we are reading at P node will be displayed on the bar graph. The bar graph is, that means the value will be displayed by this bar of LEDs one by one on the value of received analog on pin P0, and it is up to 1023. Take a look that what is 1023. What is 255, 0 to 255, 0 to 1023. Check it there, writing on Google 1023 in Arduino, and you will get an idea about this. So this is a simple program which is running forever. So whatever value will be reading at P node, analog value will be displayed on the graph. Now moving to another application, which is compass. As I told you, that it is fitted with accelerometer, compass inside in this microbit. So microbit is fitted with these sensors: Bluetooth module, accelerometer, magnetometer. That means you can check the direction. If you want to check whether it is east or west. Rehan, what was that to show compass? Microbit compass, eh? Yeah. Microbit compass. So what we have done here, we have used this microbit. This is a plate which will be indicating north or east, or west. Something happened, something wrong happened. Microbit.org. Microbit.org. I am opening its website, Microbit Compass. So what is there? This is the compass as you are seeing on the screen. So if the value is between 0 to 90, or 0 to, if it is 45, it will be indicating as northeast. If it is 0 degree, it will be indicating as north. If it is 90 degree, it will be indicating as east, 180 south, 270 west, and so on. So with the help of this compass, you can program it. Okay, so when we run a simulation, then we'll check it. This mistake I have made. So this is the compass I have selected here. This is north. If it's 270, it will be indicating 95. It should indicate east, but it's not indicating. What happened? Rehan? Something happened to the Tinkercad, sorry. But anyway, when we are checking with the compass at 268, it should have indicated as west. So we have programmed it using this diagram. So whatever value you want to, okay, exactly 270, okay, 90, 90, 90, 90, 90, 90, 90. Now Sanket told me that we need to keep it at 90-degree exact. Now it is showing east. So when we have kept it at 90-degree, it is showing east. Now again I'll show the compass. 180 south, we'll check it. 180. We'll make it 180. 180. Now it is showing south. So based on the value which you are feeding in your program, checking out this compass, you can make your project. Let's say you have fitted in your vehicle, in your bicycle, and you want to check the direction in which you are heading. So you can fit it there. So based on the direction, it will keep on telling you the direction where you are in direction in which you are moving. Now we'll check the code. What we have done here in the code, that set degree. This is again a predefined block given in the Tinkercad. You can check it here. So you can set the degree which is provided by compass. So compass heading is giving you continuous reading, which is stored in a variable named as degrees. Now we have set certain condition. If degree is equals to 0, then it should indicate north. If degree is indicating 90, it should indicate east. If degree is indicating 180 degree, it should indicate south. And if it is 270, it should indicate west. We can change the program. What we can do, if degree is between 0 and some value, you can make it in this way. If degree, you can put a block here, comparison block, and you want to make it like this. If degree is between 350 to 10 degree, you want to display it north. In the similar way, if you want to display east, you make a band of 80 degree to 110 degree. So you can change that program also. There are various possibilities to make the program, to write the code. We have fixed the values 0 degree, 90 degree, 180 degree and 270 degree to display north, east, south and west. If you want to display northeast also, you can add those instructions there and fix the value at 45 degree. So whenever your compass will read for 45 degree, it should indicate northeast. And in the same way, you can display other directions also with the help of your writing the code in the coding section. So this is our compass here. I have shown you. Now we have, excuse me. Now you can check this infrared sensor also. You can interface infrared sensor also. You can interface your RGB LED also. We have temperature sensor also. This means light, because light sensor is also there, but I'm not going to discuss them. You can interface your infrared sensor, that whenever an object will come there, it will be indicating something on the screen. You can use temperature sensor, as you are seeing here. Based on the temperature, you can indicate the condition of the temperature in red, green and blue light. And you can also use your light sensor. You can make that also, as you're seeing here on the screen. Tyrannosaurus, Java, C++, it's very complex and hard. Rahila, Java is in gaming program, easy. Students, there are various programming language, Java, Fortran, Python, C, C++, but at this age, where you stand now, is learning these languages will be a little bit difficult. And for you people only, people have designed virtual programming, so that you don't get puzzled. You don't have to hamper your current studies. Keeping your current studies in mind, scientists and developers have designed virtual programming, so that you can understand programming in a very simple ways. So don't waste your times in learning and putting efforts in learning high level languages. Just try to focus on developing your logics with the help of visual programming. Now, okay, anyways, moving to this uh, project where we have used this passive infrared sensor. So whenever there will be movement, it will be indicating by X. Otherwise, it will be indicating by smiley. So whenever there will be movement, it will be indicating by X. Again, the code is very simple. What you want to display. So when we read something on pin 2, because we have connected this infrared sensor with pin 2. So whenever it will be sensing anything on pin 2, we need to display X. Now let's say I don't want to display X. I want to display I. So that means incoming. So I want to display I, and no problem. Instead of displaying this, I will display I, a big I. So I am changing the pattern on this 25 LED display. Now let's see. I'm starting the simulation. And now you'll see that whenever there will be any movement, it will be displaying I. Otherwise, a smiley will be displayed. So this is how we can use it with this passive infrared sensor. Now, this is a temperature sensor here. So this is there showing if the temperature is high, it will be indicating red. If it is low, blue, medium, green, and high, red. You can check with the code here also. The code again is not big or difficult. You can see that plot the bar graph. What do you want to display on bar graph? A temperature. And up to 50. What range we have fixed? That it will be sensing the temperature maximum up to 50 degrees Celsius. So we have fixed the value range here, maximum range. And if it is greater than or equals to 32, we want to glow red LED. If it is less than 10, we want to glow blue LED. If it is greater than 10, we want to glow green LED. So like this, you can program, you can code your Microbit. But comparatively, Microbit is a little bit costly, and but it's easy. So, but we have another options also, Arduino boards, Arduino controllers. We can go with Arduino controllers. So, guys, we have finishing up here with the projects. Now we'll be discussing about the projects which we are going to allot you, uh, which you have to submit in a next session, before next session, not next session, before next session. That means up to Friday, next Friday, coming Friday, you need to submit these projects. So we have not these projects, we have two projects, so you need to submit any one. So the first project we have here is firefighting system. So take a look on the diagram I'm displaying on the screen, and write the comments if you want to ask about anything you have learned in these sessions. Microbit is more easy and interesting than Arduino board. So no, it's not like that. That it's very interesting. Only thing is that it is fitted with 25 LEDs. Although it is good, it is easy, but it's not like that. That it is more interesting than Arduino. In both of the controller, you need to do you need to do same thing. Interfacing techniques will remain same. Keep this in mind. Whatever interfacing techniques we have learned in our sessions, that is in standard ways. Those are the standard ways by which we interface our sensors, components, output devices with any of the controller. So interfacing will remain same. You only need to, only thing is that type of controller may change. That you may be using Arduino, you may be using some another controller, ARM controller, you may be using Microbit, but things will remain same. Even programming logics will also remain same. But it's not like that Arduino is not interesting. Arduino is also interesting. It's You can make it more interesting by fitting your own LED panel. You can design your own LED panel. You have 25 LEDs in Microbit. You can fit 50 LEDs, make your own panel, display whatever you want to display, characters, numbers, images, whatever you want to display, you can display on that panel. Okay. Kavita, sir, show the code being used here in temperature sensor, light sensor, temperature sensor. Kavita, which code you want me to repeat again? Robot. Okay. I'll show you the code for robot. Everything is individual class. Don't worry, these videos will be there on YouTube. If you feel that we need to check uh, things there, you can check there on in the videos. Anyway, I am showing you the code here for the robot. So this is the code which we have written for this mobile robot. So what we have done here, if we are reading digital pin 6 high, and 6 is connected to 6 is sorry 6 is connected to forward. So if 6 is high, what we need to do, we need to run both of the motors in forward direction. So what we are doing, we are setting pin 5 and pin 2, both of the pins high. That means pin 2 and 5 are connected to pin 2 and pin 5 are connected to input 1 and input 3. So if, as I shown you, that what we are doing here, we are applying this pattern. If forward button is pressed, we want to run the motor in forward direction, both of the motor. So what we are applying? We are applying 0101 in both of the cases. Then in next step, otherwise keep the pins low. Otherwise keep the motors in off state. If pin 9 is high, what is pin 9? Let's check. If pin 9 is high, pin 9 is connected to left. So if you want to run the motor in left direction, what code we have written? We have written that if pin 9 is pressed, set pin 4 high and set pin 3 high. That means we need to run one motor in forward direction and another in reverse direction. So the pattern is for right motor, the pattern will be, let's say, 1 0, and for right hand side motor, the pattern may be 0 1. So it depends on the connection, how you have made it with L293D. But thing is that when we have coded it, we need to set the parameter, set the pins high and low based on the condition you have used in your motors. But motive here is, let's say we are pressing this button, we need to fix these inputs, this input pin, this one, and input pin 2, in such a way so that my motor 1 should run in forward direction, and in a similar way we need to fix this input pin 4 and input pin 3 in a way so that my motor 2 should also run in forward direction. In the same way, if we press this button, my pattern on this input pin 1 and 3 should be to run the motor in forward, and this connection for pin 4 and pin 3, input pin 3 should be to move the motor in reverse direction. So that depends on how you are programming, how you want to rotate your motor in forward or reverse direction. Based on that, you keep on writing your code. So this coding is written for one condition in forward, in reverse direction, for left movement and for right movement. Okay, so nothing we are doing, based on the condition, based on the condition of the push button we are reading there, we are running our motor in forward and reverse, whether it is forward or reverse, left or right. Okay, now moving to the projects which we are allotting you. So the first project is firefighting system, where you need to use one Arduino board, one gas sensor to to check, to sense the concentration of gas, one motor which is used as a pump, a piezo to indicate or for alarming, and one 293D IC to drive this motor. So what you need to do in this project, you need to indicate the intensity of the gas. If it is less, then you will be indicating by green LED. If it is high, you need to indicate with red LED. And in the similar way, if gas concentration is low, the piezo speaker will remain in off state, and if the gas concentration is high, you need to turn on the piezo sensor, a piezo speaker, and you need to turn on the motor. And this 9-volt battery is there, which is used to drive this motor, when, as we have shown in this previous example of motor. So this 9-volt battery will be used to connect this red with this power line 2 to drive this motor. So using these components, you need to execute this project. Now if we talk about the flow chart, this will be the flow chart. If there is no smoke, sensor is not detecting anything, or if it is not, it's not detecting enough gas to turn on the speaker or motor. So in this situation, you need to turn on green LED, and you need to turn off red LED, motor off and piezo off. So there are two conditions: if gas is there and if gas is not there. So if gas is not there, gas concentration is less, then only turn on green LED and keep these things in off state. If you detect the gas, then you need to turn off this green LED and turn on red LED, motor and piezo electric speaker. So this is a simple flow chart for this project. So these are the components, and these are the resistance which you will be using to drive your components, LEDs or your gas sensors, etc. So this is our flow chart. Then our next project is automatic door control. So what you need to do here, that you need to use one ultrasonic sensor, that whenever you are coming in front of ultrasonic sensor, your door start opening with different angles. Let's say you are far from gate, so the door should open by a certain angle, let's say 30 degree. If you are coming close, then 45, 60, 90, 180. So you need to use these components: one micro servo motor, one ultrasonic sensor with Arduino. Programming will be quite very simple. Only thing is, based on the distance sensed by the ultrasonic sensor, you will be actuating your servo motor angle: 0, 30, 45, 90, 120, 180 degree. So this will be the flow chart. Start the processing, read the distance which is measured with the help of ultrasonic sensor, and write the distance on servo motor. So based on the distance, your servo motor will change the angles. And like this, you will execute your project too. So these are two projects here, and you need to submit any one. And it will be good if you submit both, but it's not mandatory. You have to submit any one of the project, completing them before Friday or on Friday. 12 a.m. Sorry, 11 p.m. Friday. By 11 p.m. Friday, submit the projects in PDF. Take the screenshot and submit them in PDF. And please, please, please send your selfies. We want to make we want to display your selfies. Only one student had submitted one selfie with Tinkercad. I don't feel there is any problem in sending a selfie. So please take a selfie with your Tinkercad and submit it on uh, WhatsApp. And if possible, send us a short video of feedback about our sessions, our training, about these technologies you have learned, if possible. 30-second or 60-second feedback video, if possible, please send in your voice. Okay, if you have any query related to these projects, you can ask now. We are finishing this session. If you have any query related to these two projects, if you have any query related to this project, this mobile robot project, you can send the message on WhatsApp. First, take a look of this project, what we have done here. Check it by yourself once, and check it by yourself once. And if you find any difficulty, you can WhatsApp us on our WhatsApp number. Sanket, write the WhatsApp number there. You can write the message there. And if you have any query related to these projects, this firefighting and this automatic door opener, you can write in the comment section. We have finished the session. Those who want to go, they can go, but those who have query, they can do. Educational learner, this is what you have to do. This is what your task. You need to complete this project based on the learning. You need to find that how to connect these components. You can refer previous videos. If you find any difficulty, check the videos, check the gas sensor video, check how we have connected gas sensor there, check how we have connected motor, DC motor in our previous video, check how we have connected piezoelectric speaker with our video, and then program it. If you find any difficulty, you can message us. But now if you have any query, you can write in comment section. Shinoy Mariam, we have given you two projects. Any one of you, whichever is comfortable to you, you can submit any one of these two projects. Either your firefighting system or this automatic door control. No problem. We'll send you the flow charts also. No problem. We'll send you the flow charts also. No problem in that. Or you can take a screenshot of flow chart in the video itself. Shinoy, any one project out of these two. Thank you, Vithal. You too. But please submit your projects, all of you, if you want to participate, if you want to win that free Arduino practice kit. Certificates will be allotted to all. We will award certificates to all students who have joined us in these sessions, in any of the 3 sessions. And most probably you will get your digital certificates in next session. Thank you all for joining again today in this session. I appreciate your efforts. I appreciate that you have shown interest in STEM education, and I assure you this will definitely help you in your current studies, in learning your in learning your physics, your science, your mathematics, whatever.